There are about 6 things we're doing to enhance a typical USGA recommended rid zone in a putting green. First thing we're doing is a variable depth, where areas that are prone to being droughty near the surface, high areas, ridge lines, that's being dug slightly shallower, so it'll end up with, say, like a 10-inch deep rid zone, 9 to 10 inch, and that just kind of feathers out as the ridge line mellows out. In low areas that tend to be wet in valleys, it's the opposite. It's overdug slightly, so there might be up to 14 inches of mix. We try to balance that out throughout the whole profile. We do that by first digging the cavity with a backhoe, mini backhoe, at the traditional depth to accept the 4-inch pea gravel and the 12-inch mix. And then we identify the areas that need to be manipulated, and we'll do the fine tuning with that skid steer. So that way there, as long as we don't import any fill or export any material out of that cavity, we know it will balance out. So it makes budgeting a little easier. The other thing we're doing is we're using the finest pea gravel I can get that meets the standards and works with the mix. The finer pea gravel will lessen the perched water table effect, I guess is the best way I can put it. Another thing we're doing is later, when this green is ready for full float, we're going to remove the barrier around the lower ends of the green. So in this green, for example, from about where this stake is here to about where that red flag is there, this whole area will be removed. That way there, as this water wants to kind of seep down to the low area of this green, the native soils will help wick that excess moisture away. Another thing we're doing is the drainage system was installed with a complete loop system around, connecting all the laterals. And where that white stack is back there, we have ports that we can blow air in. So we're going to be able to manipulate the soil gases at will with just a blower. The other thing we're doing that's really exciting is using PC drainage in these lower areas. That's what this rope is here. And you could see, for example, let's see if I can see how soaked it is right now. Let's see if see the water. So basically this system is connected with the drainage system underground here. Underneath here is a lateral pipe, and let's see this one. See all the water coming out? What that does is basically a USGA rid zone works with that perched water table. Basically what we're doing is kind of making a bathtub, and it will flush once the rid zone gets saturated. And that flush is pretty important because that helps draw in that fresh oxygen and helps replenish fresh water. But the water that is trapped, that's the capillary water that's creating that dark band. As you can see, the top pile over there is kind of lighter color. You can see where the sand is more wet. Well, we want to make sure that water is always flowing. We don't really want pockets of water to stand too long. It's not good for soil gases and things get anaerobic. So basically this bathtub effect is being interrupted slightly with this rope, the PC drainage, in these low areas, kind of creating a slow weeping drain at the bottom of a bathtub. It's kind of the best way I can explain it. We made some models over the winter months, and we tested this. We talked to the inventor, Dr. Ed McCoy at Ohio State. He's really excited about the concept. He really invented it for poorly draining greens that are existing, not really in construction. So this is going to be really fun to see. So that kind of highlights the majority of what we're doing. The mix itself is also enhanced, where we are adding biochar and compost and a whole slew of pre and probiotics. We also feel that a high sand based green is a little weak in the microbial community, especially at establishments. So we want to do whatever we can to create habitat niches for favorable biology and introduce favorable biology in the beginning. in hopes that it establishes itself, including known beneficial strains of things like Bacillus and Pseudomonas and Trichoderma and mycorrhizae, and deliver a community of organisms that will sustain itself and relate with the plant. The plant will kind of farm it, if you will, with the exudates to the roots, and enhance nutrient cycling, disease suppressiveness, perhaps nematode tolerance, and just overall plant health. We've shown in our greenhouse study and some plots out here an enhanced drought tolerance with the microbes, for example, as well. So the whole thing is to have a more sustainable system that's long-lived and require fewer inputs and still deliver a high level of playability.